So in the last two videos, we solved for all the members, all the vector forces within the members of the free body diagram, as well as the reactionary forces and all of that. All we really have left to do is redraw our free body diagram, but with the numbers plugged in. So I'll go ahead and redraw our free body diagram here. We got A, we got B, and we got joint C. And downward, what do we have? We have a 50-pound force, and hopefully this is pretty intuitive, pretty obvious how to do. We got a 50-pound force going to the right over here. And then therefore we got a member under compression to cancel that 50 pounds out. So this is 50 pounds as well, and this is obviously compression. Just looking at our arrows. And I mean, there's really not that much new in this. It should be obvious at this point how to draw the arrows and how to plug everything in. But we've got BC was 71 pounds, and of course it is because it had to cancel out both of these forces. So we could say A squared plus B squared equals C squared. And you might say, well, what about joint B? How does 71 pounds cancel that out? Well, we also had a leftward force of 50 pounds and an upward force of 50 pounds of Ruby, or reactionary force at joint B in the y direction. So A squared plus B squared equals C squared as well. This will cancel, or the x and y component, I should say, of BC will cancel that out. Cancel out both of these. And that is why, that's another reason why I should say, we could say that joint A and B is 0 pounds of pressure. And that could be tension or compression, really. It doesn't really matter which one you call it, because it means the same thing ultimately. That is, well, we already saw that joint A, or the reason why that this had to be 0 pounds was there was no other force acting on joint A in the y direction, so it couldn't cancel out. But you might have thought to yourself, well, wasn't there 50 pounds going upward at joint B, so shouldn't this be 50 pounds? Well, no. Joint B was canceled out. The 50 pounds in joint B was canceled out in the y component of vector BC. So if it was already canceled out here, there's no force acting on member AB at all. So you could call it 0 pounds of tension if you wanted to, or 50 pounds of compression. It doesn't really matter how you draw those arrows, because this ultimately means the same thing. And so hopefully this is kind of obvious, kind of intuitive how the system works, and hopefully you can see that you can solve for trusses pretty much any way you want it. It doesn't matter how you draw them, they all kind of work the same.